Hello and welcome back to the channel. Today we are looking at a classic problem, which is two-sum, which is given an array of integers, nums, and an integer target. We want to look for the indices of the two numbers in our array that add up to our target. So we can assume that each input would have exactly one solution. We cannot use any same element twice, and we can return the answer in any order. This is a fantastic problem to review and go over and be familiar with, simply because it does show up a lot in interviews, and it is part of the top interview 150 on Leetcode. So to go over the problem description, really good to understand the problem. If you hear this in an interview, just kind of reiterate what the problem is, and maybe even jot down, how you would solve it on paper in this case here. So if we look at, let's get our freehand tool. So in this case, we have a target of 8. We want to return the indices of the numbers in our array that add up to 8. And we can only use each number once. So if we were to go through this, we would see there's a 3. We'd see there's a 4. The index or the numbers that we want is we want this 4 here and we want this 4 here. So these two would add up to 8. Now, let's go ahead and take a look at how we would solve this. There's two solutions we can look at, with the first being brute force. And again, in any interview, whenever you're given a problem, it may be good to mention how you would go about solving it via brute force without even writing any code, but just mention, hey, I could solve this with brute force. The brute force solution for this problem would be basically writing two loops. We would loop we would have our I iterator and our J. And once we loop twice, like if we had a 4, let's say we were iterating with, and we say 4J, we would basically go through and we would find the complement using, for every single number in the array. So not ideal, but it is a brute force solution, just kind of something to get the conversation going. So yeah, it may be good to just describe the solution and then go on to describe the time and memory complexity. So brute force in this case would not be ideal. For time, we're looking at an O of n squared, and memory would be a constant, or O of 1. Whenever we're looking at complexity, oftentimes we want to optimize for time over memory, simply because memory, we can just add more memory and expand memory or hardware. So time, we really care more about time, as that is really our constraint that we're trying to optimize for. So if we look at our one-pass hash map, which is what we'll implement, we can see we've actually traded off memory for time. We've gotten our time down to a linear O of n, and then we are at the sacrifice of memory. Memory is going to increase to also from a constant to linear, simply because we are using an additional storage, in this case, a hash map. So let's go ahead and look at how we would implement our solution. Solution number 2. So we got two-sum. We've got our integer array. We've got the target that we're looking for. And we are going to create our map. This will store the numbers that we've seen so that we can calculate our complement. And then we're going to return, and this is the case where there's no match, so we're going to return an empty array. All right, so let's go ahead and create our loop. We can iterate through nums. And the reason we want to do this is so we can then say, we can get our complement. And so this is where we can basically calculate the complement, or the number which we would subtract. So we would say target minus, and in this case, like let's say our target is 8, we would go through, like the example we saw here, we would be able to say, okay, let's subtract each one. And then we can say, okay, so when we know that when we subtract 4, we get 4. And then that way we can go through our integer array and we can look for the actual complement. So that's what that is storing. It's storing the complement. I think it's important here to also note that we're doing subtraction. And so the order is very important because with addition, we don't care about the order, but with subtraction, we need to be very careful because we don't have the same property, the associative or communicative property that occurs with addition. So in this case, just be careful. I think there's times when I'd put nums minus target, so always just be aware that we're subtracting the current integer that we're on in the array from our target. All right, so next, we want to say map.set. Here we're going to just set the index and also the integer that we're currently observing in the array. We're just going to store that. We're essentially storing the integer that we haven't yet seen. And then in this case, we can then go along, we can say map.has. If we've seen that complement, then we can go ahead and we can return. We can say map.get complement, and then we can simply return the index of that item. So in our case, let's go ahead and take an example. Let's say we want to look for, let's see, okay, so toSum we've got here, and then let's first look for something that doesn't exist. So in this case, we should get an empty array. We've got toSum, so toSum. All right, and then let's go ahead and look for, let's see, 18. So that should return 1 and 2. Let's see if that does. All right, 1 and 2, and then 9, 0 and 1 are the indices that we're expecting. All right, so pretty simple solution when we've got a one-pass hash map. This is a great one to know. It does come up a lot in interviews. And yeah, thank you so much for joining.